Hello, fellow foodies, and welcome back. This is Dr. Cassandra Quave, and you're listening to Foodie Pharmacology, the science podcast for the food curious. This week on the show, we have a very special guest. Dr. Selena Ahmed is the global director of the Periodic Table of Food Initiative and the Dean of Food EDU, based at the American Heart Association. Selena has carried out food systems research and outreach for the past 20 years with the goals of informing solutions to enhance human and planetary health. She joined the PTFI from Montana State University, where she was an associate professor of sustainable food systems and the director of the Translational Biomarkers Core Lab facility. She brings a transdisciplinary training, including a postdoctoral fellowship in chemical ecology and human clinical nutrition, a PhD in biology and plant sciences, a master's in ethnobotany, cultural anthropology, and a bachelor's in economics, which is a really cool combination, covering the full spectrum of econ to biology to chemistry. Selena lives with her family in Bozeman, Montana. She's also the author of Tea Horse Road, China's Ancient Trade Road to Tibet, as well as Botany at the Bar, The Art and Science of Making Bitters, which is one of my favorite books that I keep by my bar when I'm whipping up bitters. So nice to see you again, Selena. Thanks for coming on the show.
Thank you so much, Cassandra. Wonderful to be here.
Yeah, so we've been so incredibly fortunate to speak with a number of guests that are connected in some way to the Periodic Table of Food Initiative. And I really wanted to have you on the show to maybe help give us a better global perspective or an overview of kind of where the PTFI is going and how all these amazing projects connect together. So maybe we can start there. Can you tell us a bit about what the PTFI's North Star is, like what drives this initiative?
Yeah, wonderful. So we're really driven by the North Star of creating a shift in how we manage food systems to one that focuses on biodiversity as well as food quality. As you know, so much of our agricultural history has been dominated really in the past 100 years, focusing on crop yields, focusing on calories. And so much evidence in the past few decades is really pointing to the importance of looking at nutritional yield and really the quality of the foods that we're eating. And so for the Periodic Table of the Food Initiative, we want to drive this paradigm shift where crop quality, food quality is central to how we make decisions. And so we have developed these set of standardized multi-omics tools to enable labs in countries around the world to really begin to understand food composition, as those different components in food are what is driving quality and food quality more broadly. And ultimately, our North Star is to lead food systems transformation for healthier agricultural systems, healthier ecosystems, and healthier and more nourishing populations.
That's amazing. When we think about food quality, at least when I was younger, learning about the food pyramid and kind of broadly about caloric intake. But I think what this multi-omics approach does is it takes things so much deeper, right? We're really trying to understand, what is food made of? Why is that a hard question to get at? Why don't we know already all the elements to our foods?
Yeah, great question. And it's so complex. And the more we, begin to understand what is in our food, the more we understand we just don't know. And there's just, my daughter, she's 5.5 years old. And the other day she was asking questions about, how is food made? And we were at the farmer's market and we kept on kind of going one step back. And then she was like, well, how is that tool made that then processes that jam? And she's like, well, how is the tool made that makes that? And eventually we get to like the start of life. And then we get to like the planets in the in the universe and like the number of galaxies. And um, just like there's so much unknown there. It's very similar for what is in our food. We just haven't done that deep exploration. And so while there's been so much advancement in really the last 150 years in understanding sort of the basic overall macronutrients and micronutrients, we still, even for those macro and micronutrients, don't have this comprehensive, nuanced understanding. So often we think about total fat, but more and more we understand there's thousands of lipid components. And each of those lipid components has a really different impact on our body. Likewise, we often think about total carbohydrate or total sugar. but some of those carbohydrates are fibers, and some of those components, the way they're linked together, really have positive impacts on our body, including our gut microbiome. And so we're really just, I think, at the surface of understanding what is in food. And the deeper we go, in addition to those, there's just tens of thousands of unknowns. Um, and as we're beginning to understand what those unknowns are into just understanding the formulas, then taking it to known structures. And then we have to understand what is a function in the human body and what is a function of those compounds and ecosystems more broadly. And so there's just a tremendous amount of um, knowledge to be had. And that's why I think, it really is taking a global village, a global ecosystem to get at this question. And this is why the Periodic Table of Food Initiative has really dedicated, 5 years trying to develop these standardized tools to understand what is in food and then distributing these to partners around the world. And it's a toolbox that's very non prescriptive in the way it's applied. And so different organizations, different investigators, different community groups can begin to partner to then understand foods in their local ecosystems. And so, uh, and that's just one step. Once we understand what is in food, there's that piece of understanding the function in our bodies and the functioning in ecosystems. And that's one of the reasons that, in addition to developing multiomics tools for food, we have also developed multiomics tools for looking at human serum. So we can begin to have really make those linkages from the soil to what's in our food to human health.
Wow. And so for the listeners here who aren't as familiar with what serum is, can you tell us a bit more about what does that mean? Yeah.
Absolutely. Sorry.
Yeah,
Simplification,
go for it.
just blood. And so really looking at fecal matter, poop samples, blood samples. And so we can really begin to understand biomarkers or just indications of how food is impacting our health.
Amazing.
And Cassandra, so much of the work that you're doing, I think, begins to connect those dots as well.
Yeah. I mean, well, what I love about this approach is that you're really taking this broad systems approach, right? I think all of us, all the listeners here can agree that, like, quality when you taste it, right? Like, we have our own chemical sensors. We know what good food is supposed to taste like. A great example, speaking of kids, my daughter, she's older. She's 17 now, believe it or not. And she always says, "Mama, why do I really dislike tomatoes that we get in the US, but I love grandpa's tomatoes?"
Mhm.
And grandpa has a garden and grows his own tomatoes. I'm like, well, it's because he's growing them and you're getting them fresh from the ground. He's growing them in a very dynamic garden environment with lots of other companion plants that he has there. He's got good quality soil, versus, a commercially produced tomato that's grown in monocropping style in a different part of the world during the
Mhm.
winter and then shipped here and gas. And so, like, we do know quality, we taste quality. I guess the broader question is, do you think that from this work we're starting to understand how that quality does translate to health? Because quality is also, it's indicated in the chemistry, right? The chemistry is different between the two. Does that translate to health outcomes too?
Yeah, great question. And absolutely, just going back to your point about like we sense quality, we sense deliciousness. Um, and really my work on focusing on food quality, started in early ethnobotanical research. In my master's when I was working with Berber farmers in the Anti-Atlas Mountains and speaking about argan oil from the Argania spinosa tree, and they were talking about all of the ecological and environmental factors that resulted in argan oil of different qualities. Um, and they were not talking about the phytochemistry, but they could perceive it really based on the aroma, based on the taste. And seeing me as sort of a researcher and at that point an ethnobotanist that had come into the community, they were very interested to understand actually like how that translated to the phytochemistry. Um, and those sort of farmer surveys and interviews, and on understanding quality, I was very much guided on understanding, okay, how does that deliciousness and these perceptions of quality actually translate to its phytochemistry and ultimately to health attributes. And I think those farmer conversations really has guided my career and enabled me and inspired me to want to go back to jump from sort of cultural anthropology to also have some biological training and tools to learn phytochemistry. And that's inspired my doctoral training. And then that kind of inspired my postdoctoral training in the human health outcomes, trying to make those linkages between quality. And absolutely, I think so many of the compounds, that we're able to perceive through our senses are also phytochemicals that have different health attributes. And so, just yeah, going
Yeah.
back to what your daughter was saying about the deliciousness of tomatoes, why they are delicious. Many of those compounds we know also have health attributes. And I think there's so much science to continue to be done, just linking those dots and really bringing that evidence to scale.
That's amazing. Well, I mean, I love the connection that you all are building also with local farmers through these projects. And I know you, as you mentioned, your work on these oils during your training, but you also worked, if I remember correctly, did a lot of work on tea, right? And how tea is grown. I mean, we're talking about the types of tea that we all enjoy, the caffeinated Camellia sinensis tea. And can you tell us a little bit about what you learned about how the ways that tea are grown impacts that final product, like if it's grown in a forest versus, in a mixed garden versus in a monocrop? Because I'm wondering from those lessons, do you think that as we learn more about the omics, this is all kind of helping us to better understand there are real outcomes, real results that come from the different ways that we grow crops, and maybe this is knowledge we can share with farmers to improve our crop qualities.
Yeah, absolutely. And so for my PhD dissertation, I worked in Yunnan province of China in the uplands with Aka communities and other indigenous communities in southwestern China, really understanding how management practices impact the genetics as well as the phytochemical quality. Um, and I also learned that farmers in those communities, many of the farmers in those communities, are managing their food systems, their agricultural systems for crop quality. And the way they're perceiving it is absolutely based on flavor. So they're actually able to taste the quality. And for those farmers, it very much results in a price premium of how much they're able to sell their tea for, and very much then loops back into their livelihoods. Um, and then also there is this perception that the higher quality also has uh, higher healing attributes. And I think that links back to a lot of the earlier work that you did in that continuum between food as medicine. Um, and so then bringing back those samples to the lab and really seeing how growing practices impact the quality and the specific growing practices the farmers were using that I was very intrigued by were the agroforestry systems, were these polycultures, these diversified systems where they were not putting agrochemicals, but really relying on the structure and the function of sort of a forest ecosystem to provide ecosystem services for pesticides and for irrigation, as well as for soil quality and soil management. And so the teas from those systems just absolutely divine and delightful with their aromas and their complexity. My main research question is how are these agroforestry practices compared to sort of the monoculture that we see is really the dominant agricultural practice for tea and for so many of our crops around the world, where we are putting these agrochemicals. And so those early sort of farmer discussions and guidance also led my understanding of a sustainable food system, not just understanding the tea in the system, but all of the biodiversity that is in the system. And if we're going to be asking about tea, we have to think about all of the plants, we have to think about the soil, we have to think about how that farming system is connected to other landscapes and how that's connected to different cultural practices. And so while I never actually got formal training in sustainable food systems, it was really my field research with farming communities that gave me that training on sustainable food systems. And eventually I became a professor in sustainable food systems through my informal training in these communities. But I think just that connectivity between everything, and coming back to the periodic table of food initiative, taking that food systems approach in trying to link how we are growing and managing our crops, our foods, and then how we're processing them, how that's impacting the food composition, and how that's so important, especially in the face of global change, land use change, and with climate change. And so my research in those communities eventually evolved during my postdoctoral training to understand how climate change is impacting crop quality of tea, and how different management practices can actually bring resilience and buffer the impacts of climate change on the quality and the phytochemistry of those plants. And
It's
then how we can
amazing.
actually perceive that. And so that's really, how I got interested in it. I was having a cup of tea with some farmers, and a couple of days later, having tea with the same household. And then they expressed how the taste had shifted. I was like, oh, and at that time, I was very interested in how biodiversity management practices impacted quality. And they really drove me to actually equal or even larger impacts that are occurring because of climate change. And they suggested, well, actually, the monsoons had started, and they started earlier, and they were a lot more dramatic. And that was really diluting the quality of the tea. And so, even at the Periodic Table of Food Initiative, we're extremely interested in understanding how climate change is impacting the quality of our food, and can we implement management practices to buffer those changes?
It's amazing. Because I think it's incredible on so many levels because in the end, we're also supporting farmers and consumers really on both ends of the spectrum. Because with this knowledge, we can better inform farmers. What are some of the ideal management practices that can make your farm more resilient, make it more sustainable, have a higher quality product that then translates to higher opportunities for health outcomes and consumers. I love that systems approach and the integration of so many really cool technologies, in that
Yeah. Yeah, absolutely.
yeah,
The goal is absolutely to, go back to farmers and provide, really understand their management practices, and then provide them evidence that complements their own ways of knowing. Um, and then, because we're utilizing these standardized tools, we can begin to compare data across studies, so we can really have evidence at scale. So is agroforestry, does it really result in higher crop quality? Or is it only for tea plants or for specific plants? Or is it only for specific locations? And I think that's the beauty of the standardized tools that the Periodic Table of Food Initiative is providing. And it's, I think, also the beauty of this global approach where it's very context specific, really trying to understand agricultural practices and outcomes of a specific region.
that's great. That leads into my next question was really, about this global direction of the overall initiative because you're not just focused on, crops here in the United States, but also on a very broad perspective across the globe. Tell us a bit more. Can you give us some examples of different partners that you have across the globe and kind of what types of scientific or agricultural work that they're doing?
Yeah, so our food systems are global. We have local food systems, we have national food systems, but ultimately our food systems are global. And so we think it's extremely important to take this globally coordinated approach to understanding our food systems. Um, Also, just understanding food composition is too large of a task for any country or institution. So we really have to work together to solve this, to solve what is in our food and share that knowledge across countries and across institutions and across sectors. And so the Pure Table of Food Initiative, we are continuing to grow and set up a global ecosystem. We started with centers of excellence, one on each continent. And those include academic institutions as well as public health and agricultural institutions, different federal enterprises. And now we're continuing to grow our ecosystem with national labs. Our goal is to have one national lab in each country. And we would also like to continue to have other partner labs. And recently, we had a call for onboarding additional labs. And so we are excited to announce in a few weeks the new labs. that are joining our ecosystem. But at this point, we have over 20 institutions that are part of the Periodic Table of Food Initiative and are just so delighted of the work that they are doing and championing in their countries and in their regions to understand the composition of local edible biodiversity. Some of them are focusing more on just profiling food composition and understanding how that food was grown and how it impacts composition. Others are leading research projects, really looking at the connection of soil quality, soil organic matter, ultimately how that impacts food composition, and ultimately how that impacts human health, including the gut microbiome. So, we're really starting to make those linkages across the food system from our soils to our guts. So one of those projects is funded by the CRA Foundation and is being led in Ethiopia as well as in Ghana by our centers of excellence in those countries. So really delightful research. And I think it's that type of research that is across the food system and really breaking down those silos where we're going to have unprecedented types of knowledge. And then innovations in technology, including AI, the ability to bring those complex data sets together, data that really crosses disciplines and crosses sectors to make meaning and ultimately to give us messaging of how can we manage food systems, whether it's a farmer or it's somebody who's leading food formulation or creating dietary guidelines for local populations.
Amazing. I think that's just incredible because you're in this way you're able to see how these systems approaches work not just with one um climatic situation, right? Or if
Mhm.
we're looking at crops being grown at different elevations or different levels of humidity, or different traditional practices. But I also really like the unifying principles you have of sharing technologies across these sites, that you have standardized kits to compare data. That's really exciting. Um, Beyond, Africa, I know you have a footprint also in the Pacific. Any work also happening in South America, or what are some of the other places where you're doing
Yeah,
work?
absolutely. So, in Central and South America, we are working with Javeriana University, as well as a public health institution in Mexico City. And they're leading work looking at foods for their role in the prevention of diet related chronic disease, including lots of indigenous and traditional foods from those countries. Also, starting to make linkages between how the food is grown and ultimately the impacts on human health. And going back to your point, Cassandra, just about these enabling technologies, part of what's really important, in addition to providing the technology itself, is building the capacity. And so for that, we have started our Food EDU training program, which is really to begin to provide context of this very complex foodomics data that is being generated, and even stepping back a step and really saying, what is the role of foodomics in society? What is the role in addressing these grand challenges of our time, whether it's climate change or diet related chronic disease or degradation of ecosystems? What is the role of this type of foodomics data to complement existing ways of knowing, to ultimately develop these data driven solutions? And then we take it further in, okay, now how do we generate this type of data and really building the capacity of labs once we provide these onboarding kits, these multiomics kits, how do they carry out this work in a standardized way, both for the food composition, but also that food systems metadata that we were talking about, all of those factors associated with how a food is grown, how it's processed, how it's consumed. Um, and then taking it further and thinking about once we have this data generated, how do we analyze it? How do we apply it? And then continuing to trying to inform stakeholders that are more downstream that will ultimately utilize that data, including dietitians and nutritionists. And so that
Amazing.
capacity strengthening piece, I think, is really important in as we begin to distribute and in that global footprint, and also really making sure we've been very mindful in making sure that we're not creating inequities between geographies around the world, because so much technology in the past, multiple decades, has resulted in some of those disparities between countries, low income countries, middle income countries, high income countries. So, really making sure that we're being equitable in our distribution and our capacity strengthening as we begin to enable this very rich data composition.
No, that's such a great point. I know from my own research in different countries, especially where we have what are known as biodiversity hotspots, areas where we have rich levels of endemism. So plants are only found in this one part of the world, but also areas where you have a lot of the native vegetation being cleared. Um, Oftentimes, the research infrastructure in these regions, which are such high priority for studying the local flora, the infrastructure is just non-existent or it's really limited. And so, I think the capacity building component is so important because, like you said, like this is not something we can do as one nation or one university or one lab. This is something that takes a global network to really dive into. That's fantastic.
Yeah, and often some of the most vulnerable populations are those that don't have the lab capacity. And so, even working with some of our partners, we really try to meet them where they are in terms of their capacities. Um, and some of the efforts are acquiring new instrumentation, and then providing training on that instrumentation. And so, there's really a need to meet partners where they are.
And I think you're also building a community of young scholars,
Absolutely,
scientists. I mean, and
absolutely.
there's so much value there as well. Just building this community of people that can share ideas, share data, really dive into some of these big questions that affect us all. I mean, this affects the planet at large when you think about it.
Absolutely. And I see that community a lot, with our centers of excellence, the investigators. We've also have our Good Food Fellows program where we have these fellows that are leading these community engaged research projects in their countries on each continent and utilizing the multi-omics tools that we've developed. And you just see this really rich flow of information and collaboration that's happening. And I can just, envision all of the collaboration that will continue to happen beyond for those fellows really throughout their careers. And so I think that community piece is so essential and beautiful.
Amazing. Well, I have a really simple question, but I'm wondering if some of the listeners might be curious about this. Is when we talk about multi-omics, Um, in my head, I'm envisioning, mass spectrometry to do proteomics,
Mhm.
lipidomics, these types of experiments. Can you tell us a little bit more about like what do we mean by omics? Are we looking at compounds that or molecules or proteins where we absolutely know the identities of these molecules or these elements? Or is this also about generating data on we don't necessarily know what they are yet, but we have them database so that as those identities are
Mhm.
discovered, like how does omics work really happen? Like what does that entail?
Yeah, absolutely. And I might not be the best person on our team to answer this question, but I can take a shot at it. And so for me, omics really is understanding all of the compounds or components in something. So for food, food omics, it's all of the components that are in food. So all of the macronutrients, the micronutrients, as well as what we call the phytochemicals, the secondary metabolites, the specialized metabolites. So for the macronutrients, those are the lipids. So we have lipidomics. Those are the proteins. We have proteomics. And then for the micronutrients, and then also we have the carbohydrates, so we have glycomics, and specifically we're focusing on the fiber components. Um, and then for the micronutrients, we have the vitamins and the minerals, as well as the metals. And then we have these tens of thousands of different metabolites. And so what the PTFI or Periodic Table of Food Initiative has in our database is data on proteomics, lipidomics, glycomics, metabolomics, as well as ionomics, and putting all of that data together. Um, some of the components are known, and others are unknown. And so we've sort of split those off into a reference database as well as a discovery database. Our discovery database has our unknowns, and so we have some signatures that can let us understand from our mass spectrometry data that can help us understand the formula. Um, Yet we need additional information to help us get to the structure of what that compound is. Um, and I think advances in AI are sort of enabling us to better get there. If we think about some of the advances, for example, in AlphaFold for proteins, applying some of those same tools to small biomolecules, we can begin to go from formula to structure and then eventually to function. Um, for the proteomics data, the PTFI actually did not develop a standardized proteomics methodology. We're utilizing an existing one since it already existed. However, the application of that proteomics methodology to foods, just the first 500 foods in our database, we see there's 420,000 unique protein components in those foods. Um, and still,
Wow.
there's a
You
lot of
said you've analyzed 500 foods already? Is that what you
yes,
said?
and so
Wow.
yeah, and
Amazing.
actually yes, and actually the PTFI database, we're gonna be, having a release,
Yeah.
of our second set of foods, in a couple of months, and so it will be over 1,000 foods. But if you go into our database right now, there's 500 food, and you can explore 420,000 unique protein components. And so, I mean, I did not even imagine when we started the project that there would be such a diversity of protein components, and now trying to understand all of their targets, in the human body, is a whole other task that's very exciting. Um, Likewise, for the metabolomics data, we have an untargeted metabolomics data in our discovery database. We have over 20,000 unique metabolites. And most of those are unknown right now, but in several months, due to some unique collaborations that we have, we believe we will have an understanding of or knowns for many more of those unknowns. And so that's really, really exciting as well. Um, and continuing to work with our partners to populate the database. And so having a release in a few months with additional foods. But yeah, going back to your original question of what is omics, omics is really trying to understand all the components in something using all the different technologies. Um, and the technologies that we're using target a specific type of compound.
It's incredible. I mean, I can see this informing a whole new generation of dietitians and nutritionists, because for the first time, we'll be able to look at a molecular level into what goes into food. And I've always thought of the PTFI's relevance for understanding how to produce, what factors influence the production of different molecules or proteins that might have health benefit. But I wonder, could this also in the future be a tool that we could use to better understand food intolerances or allergens? Like, are there certain proteins that maybe oh, this protein is found, I'm just gonna say like in peanuts, like, well, is this protein found in any other like species that's consumed just so that patients would know, oh, wait, you need to avoid this one because there's a likelihood there could be a reaction. Like, do you foresee that we could use it also for those
Absolutely.
things?
Yeah, that's a great question. And last week I was visiting our Center of Excellence at UC Davis, and multiple of the investigators that are linked to the Pure Table of Food Initiative have a background in medicine, medical sciences, or in pharmacy and pharmaceutical sciences, and really bringing that lens of the medical world in terms of dose to food. And I think why shouldn't we understand food, something that we're consuming multiple times a day that's so critical to our survival as well as our enjoyment, that deliciousness. Yet we don't have that same approach when as we prescribe a drug for. And I think going back to yes, we have to enjoy food, but because it's so linked to diet related chronic disease, to these dietary intolerances, that having that medicalization of food, understanding food that in this very precise way can exactly help us make more precise guidance for people that are intolerant to specific foods. We could have an absolutely much clearer understanding of different species that have specific proteins that are linked to allergens. And so that is one of the aspects of food. and food composition and this application of multi-omics that I'm most excited or extremely excited about is how we can really shift our understanding. And I think, in several decades from now, not have food be this challenge, but really it be a source of nourishment, of enjoyment, because we have the knowledge to enjoy it and it not be linked to diet related chronic disease, for it not to be linked to degradation of ecosystems.
That's incredible. Well, and as we're talking about food, I think it's important to also recognize that you guys are talking about what I would call real food, like grains and vegetables and fruits. But unfortunately, in the sad diet, the standard American diet, which is very sad, we eat instead a lot of ultra processed
Yeah.
foods. Have you ever stuck one of these ultra processed foods through your pipeline? Because I think that would reveal some very interesting things, like take a Snickers bar and stick it through there or a McDonald's hamburger. How does
Absolutely.
that
And we
compare to a
have, and we
traditional
have.
dish? Yeah.
Yeah, we do have it's so interesting. And we have multiple. Oh, did I there we go. Um we have put some, we sort of started this focus on whole foods, and then some minimally processed foods, some fermented foods and some cheeses and yogurts and tempeh. And then we have put some ultra processed foods through the system. And increasingly we actually want to have studies where we're looking at ultra processed foods, whether it's a vegetable oil or it's a snack food or a fast food meal. Um, and one of the kind of key findings from that is it really doesn't demonize food, because even when we're talking about ultra processed foods, when we're looking at the chemical signatures, there are things that are actually there are health, compounds that are actually healthy in many of these ultra processed foods, and then there's a lot of compounds that are deleterious. And then it gets to the dose of those compounds. And so I really appreciate looking at the data of ultra processed foods, because it doesn't necessarily demonize the foods, but then when you compare the foods to something that is healthy, there's just so much evidence on the benefits of having a healthy diet, having a diverse diet. Um, and I think even when we're looking at healthy foods, um, there's just incredible amount of diversity. If we're looking at like dark leafy green vegetables, in some cases, there's more unique metabolites in each species than there are cross species. And so really kind of, emphasizing the importance of having that dietary diversity. But going back to your point, I think, when we look at, a fast food burger, there are some nutrients, and there are some, beneficial components. And so I like looking at the data because it's not demonizing the data. And then I really appreciate contrasting it to a plant-based burger or a burger that might be sourced using regenerative agricultural practices, where the bun might be, a fermented sourdough whole grain bun, using an ancient whole grain, with fresh, locally sourced tomatoes and other vegetables, and beginning to look at the contrast between that fast food burger and that more locally regeneratively sourced burger. And then not just looking at the food composition data, but looking at the other sustainability attributes, and seeing how is it not just impacting our health, but also the health of the planet. And I think that data, and the scaling and generation of more of that type of data can begin to make us shift in how the decisions we're making in our own food choices, but also in terms of policy and what foods are available to us. And going back to ultra processed foods, what ingredients should not be allowed at a policy level to even enter into a food formula. And so we can have foods that are convenient, and that have some processing, but actually in a way that's beneficial, right? That's focusing on those beneficial components.
Amazing. I
And one more
wonder.
thing, Cassandra, I
Mhm.
think there's a lot of conversation lately about like what is an ultra processed food.
Oh,
Um,
yeah. Let's
and I
clarify
think
that.
I'm excited to actually say, well, can we actually identify a chemical signature of what an ultra processed food is? Because some ultra processed foods, there's like different rankings of it, but can we actually look at it chemically and actually have an indication, a biomarker that's more precise of what a ultra processed food is?
I just basically say anything on the inside of the grocery store is ultra
Yeah,
processed foods
absolutely,
except for the produce.
absolutely, yes. Let's stay out
It's
of
fine.
that.
I know
Let's
all
stay
this
out of
stuff
those
is ultra
realms.
processed. Um, that's great. Um, one other thing when we're thinking about, the beauty of these types of tools is the power of really looking under the hood of understanding what's there and what's not there. Um, I'm also curious, and maybe we don't have this data yet, but in a prior show, we interviewed a professor that studies PFAS, these
Mhm,
polyfluorinated forever chemicals that she was detecting them in the environment, looking at pine resin of all things,
mhm.
also in herbarium specimens, which I found, of course, fascinating.
Fascinating. Yeah.
Um, but I'm wondering, are we able with these tools? I guess conceivably, you should be able to pick up signatures of those as well. Like, how often are we consuming forever chemicals or microplastics in our foods? you know, we, I think there's a lot of potential here to better understand what we're actually consuming because I'm sure, no one intentionally would eat something like that if they knew that those molecules were there.
Absolutely, and then even, like, at a regulatory level, right, can we
Mhm.
actually that data to change what you're allowed, in
Exactly.
food packaging, in food processing, at a policy level? I think that will be really important. Um And so for our untargeted metabolomics, we are able to pull in many of those compounds that are considered endocrine disruptors. Um, and our untargeted metabolomics methodology is semi quantitative. And this is where I think, for these types of compounds, for PFAS, that we really need to be quantitative. And so we are continuing to develop tools and right now we have developed several targeted metabolomics tools. Um, and I think for PFAS and these types of compounds, it's going to be really important to develop targeted methodologies so we can really understand not just their presence or their relative abundance, but really how much they're available. But absolutely, these tools are critical to look at those deleterious components in our food system. Um, and when we think about what's in food, yeah, we're lots of times thinking about what we're getting nourished by, and, um, it's equally important to understand what we're not getting nourished by.
Yeah, no, so incredibly important. And I can see, data sets like this, especially like you said, through the new innovations coming about in AI. I think one of the challenges that maybe has prevented us, I mean, would you agree with this? One of the challenges in the past has been number one, having the tools to even measure these types of signatures. And number two is really how do you decode? I mean, we're talking about thousands of different chemical signals within each test that you run. That's just it seems like an impossible amount of data to sort through. But it looks like with AI tools, we're going to get more better and better at that.
Absolutely.
Yeah.
I am very hopeful with, like, the responsible utilization of AI for robust data sets, because I think it can really enable us to synthesize and make meaning and bring together data that wasn't possible to bring together before. Um, and ultimately, for the translation of that knowledge um, and translation for diverse users throughout the food system and in health systems. And so, very hopeful on the emergence of AI tools and its application to robust data sets.
Awesome. Well, we're just about out of time. Before we wrap, I have one last question. That's really, we talked about a lot of really exciting projects that PTFI is already actively running and some plans for the future. But what are you most excited about for next steps for the initiative?
Yeah, I am excited for the ability of the Periodic Table of Food Initiative and its ecosystem to scale. So, really scale the number of foods that are in our database and are profiled, that edible biodiversity around the world, um, scaling the number of biomolecules, and then also scaling the integration of the multi-omics tools in diverse research projects, including in regenerative agriculture, in food as medicine, in school feeding programs. Um, and then so we can really begin to have evidence at scale of how agricultural practices, how climate change impacts food quality, food composition, and then what are the implications for human health. And then the translation of that knowledge so we can better manage food systems, provide guidance at the farm level, provide guidance at the food formulation level, and provide guidance at the dietary level. And then even for food waste. And have all actors, I think, within food systems empowered to make those decisions. And so really provide more training. Ultimately, I am excited about the young scientists and the young food system leaders that will have this knowledge and be inspired to really have innovations that we couldn't imagine. And so, yeah, in the future, I think there's going to be all sorts of innovations that will be unlocked with this type of knowledge, and we will be able to enjoy food in just such a different way and really shift our relationship to food in some ways that are very traditional and ecological, and in other ways just very futuristic and we don't even know.
Amazing. Well, I'm looking forward to learning more from this system, and being able to tell my daughter what is it about that tomato that makes it so delicious. What is the secret to the quality there? I think it's so exciting what you all are doing, and thank you so much for coming on the show. Where can we send people to learn more about the PTFI?
Absolutely. So we have our website, which I can drop the link in,
It's the
and
foodperiodictable.org. Is
yes,
that the one?
absolutely. And if you are interested in exploring data, there's a link to PTFI's marker lab databases, both the reference data as well as the discovery data. And in the future, we plan on having data in different formats. We also have open access trainings on foodomics and society that are available. Um, and I believe our previous speakers from Food EDU shared the links for that, but just wanted to make a shout out for the Food EDU content as well.
Absolutely. And for folks wanting to learn more about some of these specific projects, we had a number of just incredible speakers in our last season that are tied to the PTFI network. So definitely head back to our archives. You can find those episodes on our YouTube channel at Teach Ethno or on our website at foodiepharmacology.com. Well, thanks so much, Selena, for coming on the show. I appreciate it.
Thank you, Cassandra, for having me and for all the work that you're leading.
Thanks. All right. Thank you to you, our listeners, as well, for tuning in. Again, we are in season 7 of Foodie Pharmacology, the science podcast for the food curious. We are reaching listeners across the globe. I'm so excited to be able to continue to bring this show to you. I want to thank our producers, to Rob Cohen and Christine Roth, for bringing this show to you each and every week. And thanks to you, our listeners, for tuning in. Again, if you want to find these and our older episodes, go to foodiepharmacology.com. Thanks so much for listening. Stay healthy out there, and we'll see you next time. This Foodie Pharmacology podcast is part of a special series co designed with the Periodic Table of Food Initiative, also known as the PTFI. The views and opinions in this podcast are those of the presenters and represent the synthesis of science. The PTFI is a program of RF Catalytic Capital managed by a collaborative team at the American Heart Association and the Alliance of Bioversity CIAT that seeks to advance our fundamental understanding of food composition by providing tools, data, and training to scientists across the globe so they can better characterize the quality of the world's edible biodiversity. The PTFI's ultimate goal is to advance data driven solutions in the food sector for the health of people and the planet. Funding for the PTFI is provided by the Rockefeller Foundation, the Foundation for Food and Agricultural Research, C. Rave Foundation, Fourfold Foundation, and Atria Health Collaborative.